Good evening, my lovely viewers. Welcome to Eugene TV. Let us take a look at this question once again. And of course, this is also based on an oxidation number. The question says, what is the oxidation number of chromium in K2Cr2O7? And hence, name the compound. Name the compound. Okay, this time around, we don't have option here. We have to determine the oxidation number of chromium. Chromium here is represented as Cr in this compound. And then we should be able to name the compound. Alright, I have said it before that anytime we want to determine the oxidation number of any element in a compound, it follows that if that compound is a neutral compound, the sum of all the oxidation number of all the elements that make up that compound is usually will sum up to 0. But if it is charged, the sum of all the oxidation number of the elements that make up that charged molecule is usually going to be equal to overall charge of that molecule. Okay, so let us solve it this way. We say solution. So we have K2Cr2O7. We say everything will be equal to 0. Why is it going to be equal to 0? Because this is not a charged molecule. This is a neutral molecule. It has no charge. But if this possesses a charge, let's say the charge is supposed to be plus 2, everything would have been equal to plus 2. But in this case, this compound or this molecule is neutral, so everything will be equal to 0. It means that when we add the oxidation number of potassium, we add that of chromium, we add that of oxygen, everything will amount to 0. That is what is followed. Okay, so let us say that let the oxidation number of chromium be, okay, let the oxidation number, let the ON simply stand for oxidation number. Let the oxidation number of Cr, or let's say chromium be Cr. So in this case, we are going to use Cr. Okay. So remember, potassium is in group 1. If an element or if an atom is found in group 1, the oxidation number of that element is going to be plus 1. If it is found in group 2, the oxidation number of that element is going to be plus 2. If it is found in group 3, the oxidation number of that element is going to be plus 3. Take for example, if we have, so the potassium is in group 1, so the charge of potassium is plus 1, which also corresponds to the oxidation number. Sodium also is in group 1, the oxidation state is plus 1. Okay, something like calcium is in group 2, so the charge is going to be plus 2. Magnesium is in group 2, the charge is going to be plus 2. Aluminium is in group 3, the charge is going to be plus 3. Like that and like that. So we already know that potassium is one of the elements that is found in group 1. So the charge of potassium should be plus 1 or 1. Okay? Remember, there are 2 atoms of potassium, so we multiply by the number of atoms. Let's say we put it inside bracket. Okay, plus. For chromium, we don't know, and we'll say we should call it Cr. Okay, remember there are 2 of them. Since there are 2 of them, we'll say 2Cr. 2Cr, because there are 2 atoms of chromium. Alright? Plus that of oxygen, we have established before, that is always minus 2. The charge of oxygen in most of the common compounds of oxygen is usually or always minus 2. But there are 7 atoms of oxygen in this compound here, so we simply multiply by the number of the atom there, and everything will be equal to 0. Everything will be equal to 0. So let us open up our bracket. 1 times 2, we are going to have 2, and we have 2Cr here, plus minus 2 times 7 is going to be minus 14. Everything will be equal to 0. Okay, we do away with this bracket. 2 plus 2Cr plus times minus is going to give us minus 14. Everything is equal to 0. Okay, I think we can now collect like terms. We are now going to have 2Cr is equal to, let's start from this side, 0. When minus 14 crosses equality sign, it changes to plus 14. This is plus 2. When it crosses equality sign, it changes to minus 2. Alright, so we now have 2Cr is equal to 0 plus 14 is going to give us 14. And 14 minus 2, we are going to obtain 12. So it also follows that have 2Cr is going to give us equal to 12. And then we can now divide both sides by 2. divide both sides by 2, so that these 2 cancel these 2. Okay? Let's come over to this side. So our CR now is going to be 12 divided by 2. 12 divided by 2 is going to give us 6. So that means that the oxidation number of chromium in this compound is 6 or plus 6. The oxidation number of chromium in K2Cr2O7 is 6. Now, how do we name this molecule? Or how do we name this compound? How do we name this compound? This compound can be named in the following order. Let me erase this so that there will be space for us. This compound can be named, okay, let me erase this. Since we have calculated it to be plus 6, so the oxidation number is given to, we have established that the oxidation number is equal to 6. So this compound can be named in the following order. We will call the name of this first element here, which is a metal, and then we go to the oxygen part. Then we are going to call oxygen, instead of calling it oxygen, we call it oxo. But that will not end there. We will call oxo depending on the number of oxygen atoms that is there. In this case, there are 7. So if it is 7 oxygen, we will call it heptaoxo. 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 Hepta simply means 7. Alright? So then we now call chromium. Instead of calling it chromium, we say chromate 6. That is the oxidation number of chromium. Okay, so let us name this compound. This compound should be called potassium heptaoxo. There are 2 chromium there, so we'll call it dichromate. Instead of dichromium, dichromate. Dichromate. The oxidation number was calculated to be 6, so we'll say 6 in Roman numeral and in parentheses. So this is the name of this compound. The name of this compound, K2Cr2O7, is potassium heptaoxo dichromate 6. Potassium heptaoxo dichromate 6. Have you learned something here? If you have a problem on how to calculate the oxidation number of any element in a compound and how to name compound, please just give me a DM and I will answer you. Thank you and bye for now.